Okay, so when we're doing simultaneous equations, we are looking for the intersection of two lines, and that is also known as the solution of two lines. And the word simultaneous means happening at the same time. So we're trying to find an x coordinate and a y coordinate, or an x value and a y value that satisfies both equations. So we can do this graphically or algebraically. When we do it graphically, all that means is we actually graph the two lines on a grid and we find the point of intersection. Algebraically, we can do it using elimination or substitution. So the first part that I'll show you is graphically. So I've given you an example here. Graphically solve y equals 2x take 1 and y equals 5x plus 2. So I have graphed both of these on Desmos. It is a graphing software that you can use if you'd like. You can also use GeoGebra. Desmos is a little bit easier to work with when you're first starting out. And you'll notice that I've put a dot over where the red and green line intersect. So I'll just label these lines. The red line is y equals 2x take 1. And the blue line is 5x plus 2. So the solution is this point here, where those two lines cross. And you'll notice that the x value is -1 and the y value is -3. And we write it as a coordinate. And that's our solution to those two equations. Okay, so our second example, I've done the same thing. I've graphed it on Desmos, and you can see the red line there is y equals 0.2x take 1, and then the blue line is y equals 3x plus 3. Now, for this one, you'll see that the point of intersection is not on a whole number. Okay, so the point of intersection we'll actually have to estimate for this. So I'm just going to make an estimation of about -1.4 on the x value. And on the y, it would be about -1.2 as our coordinates. And then with the graphing software, I can actually work that out. You can see the point there is -1.4 and -1.3. So our actual our actual answer would be this one here that we would write down, and you could just round to one decimal place. We'll do some algebraic examples now, and I'll do substitution method first. I'll do about 3 examples of substitution, and then 2 examples of elimination, and then 1 worded problem to help you out. So with substitution, the substitution method works because we sub one equation into the other, and the purpose of doing that is to have one unknown rather than 2. So you'll see from this question here, we've got an unknown y value and an unknown x, so it's a bit difficult to figure it out. So what we do when we do substitution is we sub one into the other to only have like the x's to find or the y's, and then we can use the known value once we've solved it to work out the other one. So I'll do a simple example to start, and then we'll do a couple of harder ones. Okay, so our first 2 equations are x equals 3y and x plus y equals 20. Our very first step when we do any of these questions is to label our equations 1 and 2. So for the first equation, it tells us that the value for x is the same as 3 times the value of y. So what that means is we can then substitute 1 into 2. So we're going to put the equation 1 into the equation 2. And what that means is anywhere we see the value for x, we put 3y, because 3y and x give you the same answer. So we'd have 3y plus y equals 20. So all I've done is anywhere I've seen x in the second equation, I've put 3y. So that means 4y equals 20, so y must be 5. Now we've worked out our first value, and we can use that to find the other one. So we would sub y equals 5 back into one of the equations. At the end of the day, it doesn't matter which equation it goes into, but you look for the easiest. So I'm going to put it into 1. and it would mean it's x is equal to 3 times 5, which gives us 15. And then, because we're looking at a solution here and the intersection of two lines, we would write our answer as a coordinate, remembering that coordinates are x, comma, y. Just get rid of that. So we would need to write our answer. So we'd say, therefore, the solution is 15, 5. And that's our answer for the first example. Okay, so for the second example, again, we label our two equations, 1 and 2. Now, the problem here is we don't have a variable that's by itself. So, in other words, we don't have a variable that's defined to be able to put it in place of the variable in the other equation. But we can have that. And if we rearrange this second equation, so what we're looking for to rearrange is we want a variable by itself on the left-hand side. So we can have that. We can have that y by itself. To do that, all we need to do is rearrange equation 2. And we're going to do that by moving the negative 2x to the other side. So we would have y equals 9 plus 2x. And then we label that equation 3. From now, we actually ignore equation 2 because we've got equation 2, it's just in a new format, and that's equation 3. So now we've got a variable, we've been told that y is the same as if we did 9 plus 2x. So what that means is we can now substitute, we can sub 3 into 1. And what that means is anywhere we see the y value in equation 1, we'll put 9 plus 2x instead. So we'll have 7x plus 10 lots of 9 add 2x equals 36. Then we expand and collect, let's just fix that up. And then collect the like terms. So we've got 27x plus 90 is equal to 36. We move the 90 over, so we take it, so we end up with 27x equals negative 54. So then x would be negative 2. Now we haven't quite finished that question, so I'm just going to go over to the next page. Now we have x equals negative 2, so what we'll do next is sub x equals negative 2 back into one of the equations. Now if we have a look at these, we can put them into 1, 2 or 3. Now if we put it into 1, we have to do a little bit of working out. If we put it into 2, same thing. If we put it back into 3, it's already in the format of y equals something, and that's what we need to find. So we'll put in x equals negative 2 into 3. So we would have y equals 9 plus 2 lots of negative 2. So 9 take 4, which gives us 5. So then our solution is negative 2, 5. Okay, so for the elimination method, it is a little bit more challenging. I do actually prefer it as a method, but it's up to you. It really doesn't matter which method you use to solve these. They both give you the same answers. So, and for some sorts of questions, it's easier to do substitution, and for others, it's easier to do elimination. So it really is a preference thing. So when we do elimination, we add or subtract the equations to remove or eliminate one of the variables. So what we're looking for in elimination method is for one of the variables to have the same coefficient. Now, it doesn't actually matter if one of those variables has a coefficient that is positive 5 and the other equation has negative 5. It's the number that matters, not the sign. So if we have a look at this question, this first example, firstly, again, we always number our equations. And if we have a look here, the coefficient of both of these equations for x is 1. So we can actually eliminate the x values here. And we can do that by subtracting 1 from 2, or 2 from 1, sorry. So if we do that, we're going to have x take away x, which gives us 0x. Then we do 6y take away 2y, which is 4y. And then 22 take away 10, which gives us 12. Now, the 0x I've only written in there just for the notes purposes. You actually, when you're doing the questions, don't need to write that once you're confident. So we can just put a line through the 0x, and we're left with 4y equals 12, which means y is 3. And then from this step onwards, it's the same as the elimination method. We sub y equals 3 back into one of the equations. Again, it doesn't matter. I'm going to put it into 2 because the numbers are smaller. So we'd have x equals 2 lots of 3. Sorry, not x equals. Let's try that again. X plus 2 lots of 3 is equal to 10. So x plus 6 equals 10, which means x must be 4. And again, we need to write our solution as a coordinate as x comma y. So we get our solution of 4, 3. Okay, so for our second elimination example, there's a couple of extra steps involved here. So firstly, we label our equations 1 and 2. Second thing in elimination method, check our coefficients. So at the moment, we have a -3, or 3 for an x, and a 5, and then we've got 2 and 5 for the y's. Neither of those are the same, but we could make them the same. And this is where we're looking for a common multiple. And we can either change the x's or the y's, it really doesn't matter. In this situation, I'm just going to change the x's. And what we're looking for is, we look at the 3 and the 5, so we look at the 3 and the 5 here, and we say what number does 3 and 5 both go into? A bit like fractions when we're looking for a lowest common denominator. Here we're looking for the lowest common multiple, which is 15. So we need to get both of those x values to 15. And to do that, we would need to multiply the first equation by 5 to get negative 15x plus 10y equals 5. And we're actually going to label that equation 3. And then we would need to do the second equation multiplied by 3 to get 15x take 15y equals negative 30. And we'll label that equation 4. Now, technically speaking, we're not using equation 1 and 2 anymore. We're looking at our new equations, and we look and see, okay, we've made the x's the same, so how do we get rid of them now? If we do take away, so if we do 3 take 4, we'll end up with negative 15 take 15, and that gives us negative 30. That's not giving us 0. We need the x's to be 0 here. So the way that we can get the x's to be 0 is if we do 3 add 4, and that would then bring the x's to 0 because negative 15 plus 15 is 0. Then we would have positive 10y add negative 15y. So positive 10 add negative 15 is 10 take 15, which is negative 5y. And then we would have 5 add negative 30. So 5 add negative 30 is 5 take 30, which is negative 25. So then we can work out that y equals positive 5. And then again from here, it's the same as all our previous examples. We sub y equals 5 back into one of the equations. And again, it really doesn't matter. You could go into 1, 2, 3, or 4 for this one. I am going to go into 1. And we would have negative 3x plus 2 lots of 5 gives us 1. So negative 3x is equal to negative 9, which means x must be 3. And again, we just write our solution as a coordinate 3, 5. So with worded problems and these questions, we have a process. We define the variables, we write the equations, we choose whether we're going to use elimination or substitution, solve them, and then we answer in the context. So in other words, we write a sentence answer. So our first example says 9 pens and 5 texters cost $3.20. 7 pens and 8 texters cost $2.90. How much does each item cost? First step, define our variables. So P is going to be pens and T is going to be texters. Then we write our equation. So it says this first sentence is the first equation. 9 pens plus 5 texters equals $3.20. Then we've got the second sentence, which is the second equation. 7 pens plus 8 texters equals $2.90. We number our equations, and then again we look at this one and it's sort of a bit too difficult to do it as substitution because we've got our coefficients are 9, 5, 7 and 8. And that doesn't really work out in terms of doing the substitution method because none of them are a coefficient of 1, and that's what you want for substitution. So we're going to use elimination instead, and I'm going to choose to eliminate the t's, and to do that I will have to get to the lowest common multiple of 5 and 8, which is 40. So to get equation 1 to 40t, we would multiply it by 8, so we end up with 72p plus 40t equals 2560. And then to get equation 2 to be 40t, we multiply by 5, so we would end up with 35p plus 40t equals 1450. And then we've got equation 3 and 4. So again, ignoring equation 1 and 2 now. Okay, then we need to work out whether we're going to add or take the equations. Now, they're both positive, so we're going to take away. So we're going to do 40t, take 40t to get 0. So we'll do equation 3, take away equation 4, which gives us 37p equals 11.10. And then to work out the cost of 1 pen, we would divide $11.10 by 37, and that gives us the cost of pens would be 30 cents each. Now I'm just going to continue over the page. So if P equals 30 cents, so P, what we're going to do now is substitute P equals 0.3 into one of the equations. We'll go into equation 2 this time. So it'll be 7 lots of 0.3 plus 8t equals 2.90. Then we work out that 8t is equal to 80 cents, which means 1 texter is 10 cents. And then because we're looking at a context question, so a worded problem, we have to answer within a sentence. So we would say pens are 30 cents each and texters are 10 cents each. And that's the question finished. Okay, so for our final example, we've got the length of a rectangle is twice its width. The perimeter is 30 centimetres. Find its dimensions. So the best thing for you to do here would be to just quickly draw a diagram up. And it says the length is twice its width and that the perimeter is 30. So the length is twice its width. That gives us an equation there. So the length is twice its width. So the length is equal to 2 times its width. And then it says the perimeter is 30 centimetres. So to get the perimeter of a rectangle, we would do 2 lots of the length plus the width, and that would give us 30. So there's our two equations. And you'll notice that this time it's actually easier to use substitution because we're told that the length is twice its width. So it means that the length, so the size of the length is the same as if we put 2 of the widths together. So what we'll do is we'll sub 1 into 2 for this one. So anywhere we see length in the second equation, we're going to put 2w instead. So we would have 2 lots of 2w plus w equals 30. Now 2w plus w is 3w. So 2 lots of 3w is 6w. So 6w is equal to 30, which means the width has to be 5 centimetres. Then to work out what the length is, we would just draw an arrow up to there. We would sub w equals 5 into 1. Again, you could go into 2 if you wanted to, but it's just easier if you put it back into 1. So we have the length is equal to twice its width, so 2 lots of 5, which gives you 10 centimetres. And then you could say the length is 10 centimetres. That looks like 16, so let's try that again. 10 centimetres, and width is 5 centimetres. And that is everything there is to do with simultaneous equations. This one was quite a long video, but you can go back over and rewatch it again. If you're just working on substitution method, just watch those first few examples. And if you need help with elimination, just watch those ones, or worded problems, you can just watch those.